Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, I sit down with my coworker, John Natkins, who's known to most of us as Natty. Natty has built a career in data, and I've always enjoyed our conversations about how the industry and technology have changed over the past decade. We talk about the Hadoop era, the introduction of cloud data warehouses, why we have so many databases in the first place, and make some predictions about the future. This is a fun episode for me because it's not so different from the conversations that Natty and I have together at work. But this time, we decided to share them with you all on the podcast. So without further ado, let's get into it. Welcome. So we have a fun episode today because I'm going to be talking to one of my coworkers at DBT Labs, John Natkins, referred to as Natty endearingly by the rest of us. And I wanted to pull Natty onto the podcast because he has a really long history of working in databases, and I've learned so much from him in conversations at DBT Labs that I thought the rest of our audience would also enjoy hearing some of his hot takes and opinions as well. So Natty, welcome to the show.
Thanks so much. It's longtime listener, first-time caller.
We don't have Tristan on today, and he usually does the background of who is Natty the human. So I'm going to do my best to get into the depths of Natty, but I assume we will not go that deep because there's so much there. But first off, Natty, when did you assume the stage name of Natty versus John Natkins? Do your parents call you Natty? Conversation starter?
They don't. Occasionally they do, and it makes me really uncomfortable. But Natty is actually a college nickname. And, the funny thing is that I picked it up in school. When I went into the professional world, I was John. So my first job out of college, I was just John. And then when I got recruited out to the West Coast, I was recruited out by some college friends to Cloudera. And there were 3 or 4 Johns on staff. I have an email somewhere in my inbox from Amr Awadallah, the CTO of Cloudera, basically saying, "Hey, there's too many Johns here already. So do you want to be Natty at?" And I was like, "Okay, here we go." And eventually it just kind of became the brand.
I have to say, my last name is Schottenstein, and I've had lots of nicknames with Schottenstein. I've been called Shots, Jay Shoddy, Shoddy. And I remember at my last job, people were like, "Oh, can I call you Shots?" And I was like, "No, you cannot call me Shots." But we could have been Natty and Shots on this call right now.
Oh, man. That would be fun. And certainly when I introduce myself, I get a handful of common responses. One is, "Oh, is that for Natty Light?" Or, yeah, Natty Light. And I'm kind of a bigger guy, so I usually point to my belly and I'm like, "No, it's more of a Natty Ice kind of situation." Or they ask, "Oh, is that short for Nathaniel?" And I say, "No, it's short for John." And I just stare at them till it's awkward.
Okay. Well, Natty, what do you do at DBT Labs? Tell us a little bit more about your profession and how you help out here.
A little bit of a data janitor. I lead the solutions architecture team for Enterprise West here at DBT Labs. And roughly what that means is that my team works directly with our customers and prospects to help them, learn about DBT, evaluate our cloud product, really just to get business value out of what we're building. And my particular territory, I get to work with some of the largest organizations in the world. So it's just a really exciting opportunity to see all the crazy ways that people use data and how they use DBT.
Very cool. And on your free time, you do a lot of writing. You write a lot about personal finance, investing. You have a Substack. Tell us a little bit more about that particular inspiration.
In another life, I think I was an accountant, and I'm just weirdly nerdy about personal finance and tax stuff. It helps that I've been kind of a startup person all my life. When I was graduating from college, I basically had an opportunity to go to Microsoft or go to a startup, and I chose the startup life. And so I've had the opportunity to see a lot of different configurations of equity. And equity compensation. And so I just find it really fascinating. And so it's an area where I think a lot of people it's hard to get adequate education. And there's not a lot of easily consumable resources. And so my goal in a lot of ways is just like make it more approachable for people who are being compensated with equity.
Yeah, no, I fully agree. It's coming from the finance world myself. I'm always surprised at how little people know about equity, and it's part of the compensation and how they get paid. And the more education, the better. So I've read your stuff and I appreciate you putting that all together. So you said you're a startup guy. Tell us a little bit about, you started at Vertica and then you went to Cloudera. You've been in the data world for quite some time. Why databases? Why data? And then I want to hear a whole lot more about that like first wave of big data companies that you worked with.
So I guess like why databases? Because my college computer science program was a lot of systems nerds who wanted to work for Sun Microsystems and graphics nerds who wanted to work on like DirectX or things like that. And I was like, databases was my counterculture way of rebelling. I wish there was like a better answer than that. But it really came out of, I interned at Pfizer of all places in a bioinformatics organization and wrote VBA macros over a summer connecting to Oracle databases and just uploading data from Oracle databases into Excel spreadsheets. And I was like, this is cool. And so I went back to college and was like, I'm going to go take all the database courses. And that was kind of how I got into it.
Okay, so take us back. I want to get into, so this was like a little bit before my time. And so I like read a lot about Hadoop and big data and what that felt like at the time. But I just want to get a better sense. So there's like, we're talking 2012. How early are we talking now when you first?
A little earlier than that. So like Vertica, I think was founded in 2005, I want to say. Maybe I might be off by a couple of years. And then Cloudera was actually founded in 2008, I'm pretty sure. But that was like very, very early start of the Hadoop wave. I actually joined Cloudera at the very end of 2010. So, kind of still early days. This is like even before the data is the new oil taglines. But there was just a lot of interesting things going on. At that time in the warehouse industry, it was just like everything had been built on like SQL Server or Oracle, and you just had these one databases. And then, the columnar data warehouses really started that, a little bit of a Cambrian explosion, kind of like, we've seen again today with some technology stacks.
Yeah. So Hadoop had this big promise and MapReduce as well to be able to make sense of really big unstructured data. And it was a lot of companies were moving towards this architecture. What did it feel like this was going to be the next big platform shift in data? What was so exciting about Hadoop in the early days? Was it just that it could process so much massive amounts of data at a time? Or tell us a little bit more about the promise.
It's a good question. And I feel like what happened, the internet happened. I think, like, honestly, that's kind of the root cause of what all of this, what was going on. Because the columnar databases, they all charge like per terabyte, which is a hilarious thing to think about now that, everybody is kind of operating at petabyte scale. But because they were these on-premise, MPP systems, you couldn't like handle a ton of data in them. And it was very expensive to purchase and operate these licenses. And so, when the internet happened, suddenly there were, I guess I'm being facetious, the internet happened a lot earlier, but like when people really, really started processing data that was being generated on the internet, it was creating all this data exhaust.
Web 2.
Yeah, Web 2, exactly. Yeah. And this is where like the 3 V's came from, like variety, velocity, and volume, I think were the 3. And, I think with, in the early days, you had just this like large volume, and to some extent velocity was kind of like the columnar database days. But when people started looking at like what Google was doing out in the world and how they were using data, they're like, ooh, I want to do that too. And Google conveniently was like publishing all these really interesting research papers. MapReduce was kind of the original. They have basically everything that became the Hadoop ecosystem was kind of like a re-implementation of some sort of Google system. And so, it allowed people to start to process wide variety of data. So like you mentioned my Substack, which is called semi-structured. And like one of the things that, really came about with Hadoop was the ability to deal with semi-structured data and process that. And, initially that looked like logs, right? Logs have some sort of structure in that there's a log4j template or something like that, but also JSON is semi-structured, right? It's got like a general structure to it, but it varies from record to record, things like that. And traditional databases just weren't good at processing that. Now, that's a little bit less true nowadays with kind of the cloud warehouses. But that was kind of what Hadoop enabled. It was really a file system with a distributed processing system on top of it that, MapReduce was kind of like assembly code for data processing, right? SQL is this like very high level language from that perspective. MapReduce was like writing Java classes to process this thing. And so, it enabled all of these really interesting use cases that people just couldn't tackle anymore. And I think some of it was just driven by like art of the possible, right? Like people were excited about data and what some of these, big internet companies were starting to do with data. And they were like, there's value there. Like, we're going to go extract that value. And in order to extract that value, we need to capture more data and we need to process more data. And Hadoop could do it just a lot more cheaply, right? It was HDFS was like way cheap compared to a Vertica or a Greenplum or something like that. The economics were dramatic.
Got it. So it did have this meteoric rise and had a lot of promise. It did deliver a lot of value much more cheaply than some of the alternatives. And when I think about like big tectonic shifts in technology, like first you have web, internet, this maybe had the need for this kind of a system. But then the next big wave that came was cloud. And, these companies that really made a business off of Hadoop, there were three really that I think rose to unicorn status. It was Hortonworks, Cloudera, MapR. Hortonworks ended up getting acquired by Cloudera. MapR had
a merger of equals, if I recall
mergers
correctly.
of equals, okay. But Cloudera retained the name, and then MapR had kind of a different, not so great outcome. But cloud data warehouses really hit their stride in like 2012 and 13 was when all of the cloud data warehouses were coming to the market. It was very nascent, but that felt like the big shift towards away from Hadoop and onto cloud data warehouses came very quickly after. What did that feel like in the market? Were people skeptical at first about putting data in the cloud? I think that was a big concern initially. It's like, oh, I'm going to put my most valuable company information in a cloud, say again, like, no, we have to do it on-prem. This is the only way we can do it. When did people start getting more comfortable? What did that shift feel like as a, data practitioner at that time?
It's funny, like thinking back to like all these stops that I made. Like when I was leaving Vertica and going to Cloudera, people were like, "Oh, Hadoop's a fad." And when I was at Cloudera and these cloud data warehouses were starting up, I was sort of looking at it, and it was like half these workloads are never going to make it to the cloud. Like banks will never adopt the cloud, and it was just like a progression of these like strongly held assumptions that were like fairly rapidly proved wrong. And I think that was honestly, that's what's been really the most interesting thing for me is kind of watching what happened with Hadoop, where it was this really new technology that just got caught as sort of a secular trend, but in a larger secular trend.
Yeah.
And so, like when I think about like, why did Hadoop rise and fall so quickly? I think it's because there was this much bigger cloud trend that Hadoop it's like if you're surfing and you miss the exactly right part of the wave, you get a much shorter ride. And that's kind of what happened to Hadoop is they just hit the wave, and it broke on them in a weird way. And it was really fascinating seeing these the cloud data warehouses start to pop up. And yeah, Redshift, Redshift came around about in 2012. Snowflake was around the same time. And, the interesting thing is that like Redshift, for example, actually came out of the MPP databases, right? Like, I don't know how widely well it's known. And I don't know, hopefully no one will get angry at me for opening the closet and showing where the skeletons are. But like Redshift was ParExcel. ParExcel sold their code base to Amazon before like they kind of went down in a fire sale. Maybe this could be my hot take of the episode. But, it's just like, it was fascinating. And so, Redshift came out of that, and Snowflake, I think Snowflake is to me really fascinating because like Redshift had all of the funding of AWS behind it, and Snowflake still like is doing really, really well. And so it's fascinating to see how that ended up landing.
Yeah, I have to say, like, seeing if the investor perspective at the time, like, Snowflake was getting really good adoption in the early days, but it was almost this time where lots of other startups were getting crushed by the clouds, where if you had a business, you go to AWS reInvent and they'd announce all the, next big products that they were launching. And you would see like startups just seeing, their big idea crushed by the cloud. And so it was like more of a precarious spot back then. Is like, could you have a new upstart like a Snowflake provide a scalable system in the cloud that could compete against Redshift or BigQuery or any of the other big clouds? Wasn't as clear, but now I think we have like a whole new cloud platform that's emerged, which in Snowflake and Databricks.
Yeah, totally. I had a job offer from Snowflake in 2014, and I turned it down because I was like, Redshift's going to crush these people. Like, it's AWS. And like, how wrong was I, right? Like, probably the worst financial decision of my career. Hopefully, DBT Labs will be a better one for me. But yeah, I think it is really interesting. And the cloud was just such a massive sea change. And I think, Databricks took a really interesting approach to it, right? Databricks took almost the exact opposite approach of a Snowflake, where they were like, actually, like, we're gonna help you run that infrastructure, but you're still gonna pay AWS for that infrastructure. Whereas Snowflake took this approach of like, no, we got it all for you, like full stack, like you just pay us for consumption. And so they're just like really interesting takes on very similar problems, although obviously they come at it from kind of different places of strength, right? Snowflake definitely pursued the more analytics, BI focused end of the spectrum, where Databricks went hard after machine learning and data engineering use cases. But now, surprise, surprise, they're meeting in the middle. So it's been super fascinating to see them evolve.
Yeah, Databricks was interesting because at the start, Spark really took off. So they had this like open source community, a lot of very heavy duty machine learning personas that were just loving Spark because it was so much faster than anything that was out there in the market. And they did have this friend or foe relationship with the cloud warehouses for a while, but I think now it's kind of settled out, where instead of competing for the cloud warehouse business necessarily, like, they have great relationships with the marketplaces, and Databricks and Snowflake end up being enormous customers of the cloud platforms, which is pretty interesting to see them persevere and then now offer their own marketplaces where lots of burgeoning startups can grow off of.
Super interesting. I have to imagine the product managers at EC2 and Redshift are just constantly fighting each other about how they feel about Snowflake and Databricks.
Totally. The thing that I find so interesting is like there's certainly some really established players now in the cloud data warehouse space. It's an enormous market. I always quote this all the time. I think the number needs to get bigger though, but there's hundreds of billions of dollars in market cap in cloud data warehouses. But yet there's some newer players that are continuing to get started, find various levels of success. A little bit, some are more mature than others, but there's Starburst, Trino, ClickHouse. You got newer entrants like Firebolt, and then even some earlier stage companies like Tabular, which is the team behind Iceberg, or OneHouse, which is the team behind Hoodie. There's all these, I'm going to use the word warehouse here loosely. I think some of them would consider them more similar to a lake house. But clearly there's a lot of variety still in the market. Like, what is the need for all of these cloud warehouse platforms in your opinion? Is there the market, can it still support, another half a dozen winners, or do you think that there's going to be more convergence around the platforms that we have today?
Just kind of coming back to a point you made in passing, I agree with you that the cloud data warehousing market here is like easily $300 billion today, probably even higher than that. And, you look at the net retention numbers that Databricks and Snowflake are both putting up, and it's just like, it's pretty incredible to see how fast it's moving. Databricks just posted 150%. I think Snowflake's last earnings, it was like 173. Like, that's insane. It is just growing so fast.
Yeah.
And so to that point, I think that that's a large enough market that, it can definitely support multiple winners for sure. I think that, the other question you're asking about these kind of other different entrants is certainly interesting. And like when you talk about like some of the ones you talked about, Trino and Starburst in general, I think is they all have interesting different strategies, right? Like Trino is really next gen federation, or like, it's not a virtualization system, but it sort of feels like that in the sense that you can query data from a single interface that exists in different systems. And, their bet on the market is, like if you talk to them, they're talking a lot about data mesh, right? Like they're really on board with that data mesh idea, because their theory is that there's going to be, every major enterprise is going to have one of everything, which probably isn't inaccurate, right? Like a lot of these organizations have a bunch of things, and like internally, sometimes that's strategic, right? Like their procurement teams are thinking, well, if we've got one of everything, we can play them off of each other, get better terms with different ones, and that can be really valuable, as long as there's use cases for all these different things. And so Trino is super interesting, but it's also a very upmarket solution, right? Like you're not going to find SMBs adopting Trino because they don't have 3 different data warehouses; they buy one. And so it's definitely something where I think Starburst has to figure out like what's our down market solution, because you can build a strong business on like a high end enterprise thing, but long term, there's like Snowflake and Databricks are making tons and tons of money off of the SMB and mid market. Yeah. And that's something that I just don't think is accessible to Trino.
Yeah, I don't know. I think it's right that they're placing a bet on a heterogeneous world. And, certainly in the largest enterprises, that seems to be a reality. There's data has gravity, and there are these systems that just seem to persist no matter what. And making a big migration isn't what companies want to do. And so Trino provides them this abstraction layer where you can query across data and not have to move it, which is, I think, a big benefit to large organizations. And Databricks also started off with a really high-end market as well. And they started as like the Rolls Royce of machine learning workloads, and now have tapped more into the SQL world as they've expanded their market share. It'll be interesting to see what Starburst or Trino ends up doing there, or if they'll find enough space in the very high end. But, it does feel like we are living in a heterogeneous world of databases. And I'm talking about cloud warehouses and databases. It's just lots of different versions of different types of technologies that do the task that a company needs.
Yeah, it's definitely not a bad bet. I talk to lots of companies that have both Snowflake and Databricks, right? It's actually quite common, or have just a variety of they're querying S3, so they're using Trino to as like an on-premise Athena type of replacement or something like that. So heterogeneous, I think, definitely makes sense, especially in the enterprise today. Some of the others that you talked about are interesting as well. ClickHouse and Firebolt, and you've got the folks over at Imply building on Druid, and Startree building on Pinot, right? They're all kind of tapping into this other type of new market around more real-time analytics, and I think real-time analytics may not be the right framing, but kind of like real-time data applications. Like Pinot is kind of an interesting tool, because I think it was originally built, and this might be wrong, but I'm pretty sure it was originally built for like user-facing analytics on LinkedIn. I think I'm not. We should fact check that. that might be a lie.
Yeah, I'll call our fact checkers, which we have. We definitely have those.
But we don't have those here. Well, whatever. I thought this was a real outfit here. Yeah, I think it came from something along those lines. But like they're all kind of going after these more like user facing or customer facing analytics tool sets. Like embedded analytics has always been a big. Embedded analytics was like 40% of Looker's business, I think, and Sisense like built themselves on embedded analytics. And so like that sort of thing, I think, is what powers the use cases for like these tools. Rockset is another one that I forgot to mention. And then, there's like other classes of warehouses that are coming out, all these streaming ones like Materialize. And you've got some really interesting systems coming out in that space. And, I think what's interesting is just there's like all, as data becomes more accessible and more usable, we're seeing this explosion of different types of data systems, which in part was what I think gave rise to some of what Tristan was talking about a bit in his analytics engineering roundup the other week. He was talking about HTAP and like, can you have one database that can handle multiple workloads? And HTAP, which is hybrid transactional analytical processing, was kind of this it sort of showed up around the same time as like the new sequels, and when NoSQL is just starting to become a term. And it was basically like systems that were generally oriented towards traditional OLTP workloads, like the stuff that you would do with just a run-of-the-mill Oracle system, but that could also do some element of analytical processing as well. So it was trying to be, best of both worlds. And like some of the earliest versions of them were like VoltDB, which you basically had compiled stored procedures that you would write, which could just run transactions really, really wicked fast, right? But they could also run these analytical types of processing. Not as well. It was definitely much more of a high velocity transactional system. And then MemSQL, which is now single store, was one of the more widely adopted versions of these. And they're kind of interesting. Like they actually started as like this in-memory row store database, but I think later on they realized that a lot of people just really, really wanted analytical processing on the side of that. And so they kind of built like Vertica clone. They might not like it called that, but that was kind of, they were modeling it after Vertica just to sit alongside their row store, their in-memory row store. And so by having those different systems, you could, then like sidle them up alongside each other and just have them perform really well. That kind of pattern shows up all over database land. And I realize this is getting kind of into like weird nitty gritty weeds, but
no, I find it so interesting because it's like when you have a job to do, you look for the exact tool to solve that job. So there's the categorization of databases make a lot of sense. Like I have a need for time series database. So I'm going to go look for a time series database, like timescale to do the job. Or, I have, analytical processing. I need to do it really, really quick. I'm going to go pull ClickHouse or whatever it is that I need for my analytical processing database. I think the categories help people figure out what that database is particularly strong at, and you have all these different kinds of jobs to do in data. Like sometimes, read writes is really important. You need to do that really well, so you have a transaction database. But other times, you need your database to do something completely different, like streaming. Streaming is just a fundamentally different way to materialize your tables, to get data like flowing through your DAGs. And you might need a streaming database often for like production-like work, often closer to data engineering types of tasks than it is for business analytics. But what I found to be like interesting here is then you end up in this very like heterogeneous world where you need to have different data stores to do different things. And wouldn't it be nice if we could just say, hey, database, you know what kind of work I need to do here, like just change how it works underneath the hood depending on the query or depending on the ask. But we found that you end up in this world of it's hard to do everything well. And so then you become a master of none sort of situation when you have one interface to try and do these different types of workloads. So in theory, I really, really like the idea of like HTAP or figuring out one interface to do lots of different types of data work. But I haven't seen it be quite successful from practitioner standpoint is because like, well, I don't need you to be great at everything. I need you to be great at this one particular thing. So we end up in this world where, you have to buy multiple warehouses. And you were talking about Snowflake and Databricks. Lots of customers have both. And so it becomes just a battle, not on customer, but a battle more on like workloads. Yeah,
it's definitely interesting. And I feel like Snowflake is coming at it more from that workload perspective, where it's like you've now got the SQL interfaces to Snowflake. You've also got Snowpark, which is Java, Scala, Python interfaces to the same Snowflake storage. And I agree. Like it's really hard to have one system that handles all of these things because they're different querying patterns. They're different insert and update and delete patterns. Right, that stuff matters. And many systems can handle some of those things, but not others. And also, like, once you get into the land of the NoSQL systems or like the geo-distributed databases like Cockroach and Fauna, you start getting into those questions of it's three letters, and I'm blanking on the last one right now. CAP theorem, consistency, availability, and partition tolerance.
Okay.
Which you start to make these sacrifices on some of these things in order to satisfy certain workloads, right? Like, if you want geo-distribution, like, you better be partition tolerant. and you better be highly available. But you're probably not consistent, because if you write on one part of the world, it's going to take a little while before it gets to the other part of the world. So you have to choose two of these things. And I think that's where, the idea of having a single system to interact with all these different workloads gets really, really hard when you're sacrificing some of these properties of distributed systems. But for like OLTP and OLAP, there's definitely common workloads, right? Where I think that, a Snowflake could probably say, we're going to do this workload and this workload and this workload, and we're just going to put it all behind a SQL face. Snowflake has enough scale where they could probably, maybe they could solve for some sort of query routing to different systems and shift that storage around underneath the covers. I don't know. It's hard to know how, I have a computer science degree, but I'm not nearly as talented an engineer as some folks are. And
I think the summary is database problems tend to be really hard. You're talking about distributed problems and systems here, and often necessarily being really great at one makes you bad at some other characteristic of a different database. And so it's hard to have this one database to rule them all end state. But I'm curious, maybe final question before we wrap up. We talked about the big wave, which was cloud, and it's always very hard to predict what these big waves are. But any thoughts on is this the final wave in data? Do we think there's going to be another enormous wave that we can't yet imagine that will replace our big systems that we have today?
I'm sure this is not the final state. I don't know that I necessarily know what there'll never be some final state unless, the sun gives out, probably. But I am certainly bullish on the icebergs and the hoodies of the world. I think that, to the point that we've been making, having a single system is hard. And while I think that appeals to, smaller organizations who want to buy one thing, I do think that, there's going to be that disparate system. And so I think that there's definitely a world where starbursts, data mesh concepts are certainly very prominent. But it also might be that you've got, Iceberg. Tabular is the company productizing Iceberg right now, just, having this storage layer that can seamlessly move from system to system. And, really it's, in some ways it might end up just transparent to a lot of the end users where they don't know that they're necessarily querying the same data. But the vendors like Snowflake and Cloudera just announced support for Iceberg, and AWS announced support for Iceberg. If they're all just connecting to some Iceberg service, then it could theoretically just be another pass through. And so, it's interesting. You're kind of pulling apart the storage and really the really, really low level data layer from the processing layer, and then the processing layer has that query bit still built into it for most systems, although things like Trino are sitting on top of that. So it's sort of maybe what's going on here is just Hadoop screwed it up, right? Hadoop was kind of decomposition of the entire database, so everything was just a different component in a warehouse, and we just had the wrong interfaces to connect them all together. And so, in some ways, the stack that includes Databricks and Snowflake and Tabular underneath it and Starburst above it could just be the next mulligan, right? We got it wrong the first time with Hadoop, and this is actually what it should have looked like now that we've, made the initial cloud mistakes, and we understand a lot more of what as a service should look like in that world. So I don't know.
Yeah, I think that's the key thing. I think as a service is what people want. They don't want to have to be a database expert. They want to just have it work and solve their problems. So to wrap up, we ask this of all our guests. Looking 10 years out, what do you hope will be true for the data industry?
Okay, I work for DBT Labs, so selfishly, I hope everybody knows SQL. Right?
Yeah, that'd be cool.
Maybe that's a
DBT SQL.
Yeah, I say that slightly facetiously, but I think that data literacy is becoming just really, really critical across the board. And I don't know if there will be easier interfaces to data, but I think one of the reasons I really love being at DBT is that we're really trying to broaden the scope of who can participate in the data conversation. And I think that as understanding and being able to gain insight from data and work with data becomes more necessary for every job, that, more people just have that kind of literacy, are able to, understand how to access a database. And I'm sure like form factors will look different. Like we'll probably get better interfaces. We'll probably, see different ways that people interact with it. But I guess, I'm just excited about the proliferation of data in a more productive way throughout the world.
Yeah. Yeah, I totally agree. I think it's all about access and empowering people to be able to solve their own questions and get the insights with data. So I'm all for that future. Where can people find you if they want to get in touch?
I am on DBT Slack. I'm at Natty. Also, my Substack is semistructured.substack.com. You can also find me on Twitter. I mostly post Wordle results these days, but I'm at Natty Ice. And yeah, I hope people reach out and say hi.
This was a lot of fun, Natty. Thank you for joining us.
Thank you. I appreciate you having me here.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.